Today's lesson is on inverses, and an inverse is quite simply a reflection over the line y equals x. So, when your teacher asks you what is an inverse, the best thing to remember, it's a reflection over the line y equals x, and you should kind of in your mind be picturing the line y equals x. The line y equals x means that 1, 1, 2, 2, 3, 3, 4, 4 would create a line that would be going diagonally through quadrants 1 and 3 through the origin. We'll show you that in a little bit. For a relation, remember, is ordered pairs. To have an inverse, it must be a function, so it has to pass that vertical line test, and 1-to-1, which is the horizontal line test. So no repeating x's on the function, no repeating y's on the 1-to-1. So this first equation asks you, what is the equation? Well, we just did transformation of functions, so this looks like the parabola moved down 2. So it would be x squared minus 2. Is it a function? Does it pass a vertical line test? Yes. Is it a 1-to-1? No, because we've got repeating y coordinates. Does not pass the horizontal line test. So does it have an inverse? No. Okay. Next one is your typical radical graph. So y equals the square root of x. So is it a function? Does it pass the vertical line test? Yes. Is it 1-to-1? Yes. It only is hitting in one spot when you draw it horizontally. So yes, then it does have an inverse. We're just testing whether it has an inverse or not at this point. Now this next one is only showing you the right side of a parabola. So we would say it's y equals x squared when x is greater than or equal to 0. Because we're only seeing, if you look at it, we're only seeing x is 0. We could see when it's 1, it's 1. When it's 2, when x is 2, okay, that's up to about 4. So, yeah, x is greater than or equal to 0. We're only seeing this when x is greater than or equal to 0. So we kind of have a limited domain here. Is this a function because I limited that domain? Yes. It is going to pass the vertical line test. Is it 1-to-1 because I limited the domain? Yes. Actually, the function part would have worked no matter what, but when I limit the domain to be only the positive x's, then none of the y coordinates are going to repeat. So it's 1-to-1. So yes, this will have an inverse. Now when you look in textbooks and you're taking your exams, the notation for an inverse is f with a little -1, like up higher like an exponent of x. So, or it could be, g -1 or h -1. Usually they use f. There are two ways to find an inverse: algebraically and graphically. All right, so to find the inverse algebraically, you basically will switch x and y and then solve for y. So, let's talk about this a little bit. If I take and I draw a point at 5, 1. If I want to reflect that over the line y equals x, I want the inverse of that point, then I currently have, 5, 1. But if I'm going to graph the line y equals x, then I would graph like -2, -2, -1, -1, 0, 0, 1, 1. You get the idea. So this is the line y equals x. All right, so now when you reflect over a line, you are supposed to go perpendicular and the same distance. So if I go perpendicular, I got to go like that. There's my perpendicular, and I got to go the same distance. So doesn't it make sense, if I had drawn this correctly, using actual graph paper, this distance needs to equal that distance, that this should be the reflected point, which is now 1, 5. So when you reflect over the line y equals x, you should notice that the coordinates are switching. 5, 1 goes to 1, 5. That's why we say algebraically you switch the x and y, and then for the algebra part you solve for y. So find the inverse of each function, find the domain, find the range on the examples. Y equals 3x minus 5. So you literally switch. So I'm going to put the x, and I'm going to put the y. So I'm literally going to switch them. So I'm putting the x first and then the y second. And then minus 5. So that's really the inverse. Find the inverse. I found the inverse, but I want to solve for y, so it's in terms of y if I wanted to graph it or do some things with it. So now I'm going to do what I'd normally do to solve for y. I would add 5 to both sides, and I get x plus 5 equals 3y, and then I would divide by 3. So y is equal to x plus 5 over 3, or 1/3 x plus 5/3 if we want slope-intercept form. So the inverse is, I always say like y -1 to imply I found the inverse, is equal to, I'm going to probably go with 1/3 x plus 5/3. But either one of those is fine. The domain, so we're looking for the domain of the inverse and the range of the inverse. So that's a line. It's y equals mx plus b, all reals. You started out with a line, you did the inverse, you get a line. And same thing for the range. All oblique lines, all reals for domain and range. Next, find the inverse. So in this case, I would write f -1 of x equals, and it's just a switching. So it's 1, 0, 2, 2, and 4, 3. That's your inverse. The domain of your inverse is 1, 2, and 4. X equals. The range of your inverse is y equals 0, 2, and 3. Next one, g of x equals radical x. So for this one, I'm going to, first of all, convert the g of x to y equals the square root of x. Remember, that's just notation. And then I'm going to switch the x and y. So I'm going to write the x there, the y there, keeping everything else intact. Now I need to solve for y. Now, remember, we'll talk about that in a second. So I'm going to solve for y. So I'm going to get, I'm going to square both sides like we did with the radical equations in one of the last chapters. And so I would get y is equal to x squared. But it has to be when x is greater than or equal to 0. Because remember, the domain of the y equals the square root of x is x is greater than or equal to 0, because when you graph it, it looks like that. It doesn't have, you can't have negatives under the radical. So your inverse cannot either. So you need to say that your g, negative 1 of x, is equal to x squared, but x has to be greater than or equal to 0. So that has to be kind of like part of the inverse. And then the domain would be x is greater than or equal to 0. And since x has to be greater than or equal to 0, then y, the range is y has to be greater than or equal to 0. Okay? D. H of x, again, I'm going to change that to y equals x minus 3 over 5. And then I'm going to do the switch. So x equals y minus 3 over 5. Switch the x and y. And then I'm going to multiply both sides by 5. So I get 5x equals y minus 3, because those are going to cancel. And then I'm going to add 3 to both sides, so y is equal to 5x plus 3. So that's the inverse. So we would say h negative 1 of x is equal to 5x plus 3. And I don't have to worry about a domain. I don't have any variables in the denominator of the original h of x fraction. So I don't have to put any like x is greater than equal to 0 or x cannot be 0. I can leave it as is. And the domain of this would be all reals. And so would the range, because it's just another line, oblique line. Okay. Next, we're going to talk about finding the inverse graphically. So to find the inverse graphically, I list out like 3 things. The first one is I find a table of values. For f of x, or g of x, or h of x, or whatever. And then I set up another table of values where I switch the coordinates for f negative 1 of x, or the inverse. And then I kind of do, when I graph it, then I check that the points are reflections over the line y equals x. Okay? So for example, negative 2x plus 3, you can go to your table of values in your calculator. I'm going to list those out there. Hold on a second. All right, so I'm going to lower it down a little bit. So x and y. So if I put in negative 2, I get 4 plus 3 is 7. If I put in negative 1, I get 2 plus 3 is 5. If I put in 0, I get 3. If I put in positive 1, I get positive 1. And if I put in positive 2, I get negative 1. So that's f of x. Now if I want the inverse, I am going to take and switch the coordinates. So I'm going to say 7, negative 2, 5, negative 1, 3, 0, 1, 1, and negative 1, 2. Because, as I illustrated in another diagram, that's what happens when you reflect over the line y equals x. So now I'm going to draw them. So negative 2, 1, 2, 3, 4, 5, 6, 7. X-axis, y-axis. If you don't have those lines in, you can draw those in. Negative 1, 1, 2, 3, 4, 5. The lines I'm talking about are the axes. 0, 3, 1, 1, and 2, negative 1. So I use a ruler normally, but it's really hard to do a ruler on this smartboard. Okay, so there's f of x. Now to graph the inverse, we switch those points, do a different color. 1, 2, 3, 4, 5, 6, 7, negative 2, 1, 2, 3, 4, 5, negative 1, 3, 0, 1, 1, and negative 1, 2. So for this one, okay. Okay, so there's f negative 1 of x, the inverse. So what I am basically then going to check is, and I just kind of draw a dotted line because it's just easier freehand to draw a dotted line. Does it look like a reflection? If we were to fold the paper along that dotted line, would the blue line, negative 2x plus 3, fall on top of the red line? And you can actually do that if you want with your own paper. So the domain of f of x was all reals. And the range of f of x is all reals. These are oblique lines. And I'm talking about, this f of x versus the domain of the inverse. But because it's a line, it's also all reals. All right, so now let's take a look at the next one. Now this one's got a limited domain here. It's saying we can only use values for x that are greater than or equal to 0. So I'm going to first take and look at f of x. So I can only go with 0, 1, 2, okay, maybe 3. So 9 minus 0 squared is 9, and 9 minus 1 squared is 8, and 9 minus 4, which is 2 squared, is 5, and 9 minus 3 squared, which is 9, is 0, and maybe one more. 9 minus 4 squared, 16, is negative 7. So if I want the inverse of that, I'm going to switch those coordinates. 9, 0, 8, 1, 5, 2, 0, 3, and negative 7, 4. So now if I graph this, let me bring up one other thing before I graph this. If I did not have that limited domain there, I could not say that this had a inverse because it would not have been 1 to 1. So we need to have that. All right, so graphing the first one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. x and y. 1, 8, 2, 5, 3, 0, 4, 1, 2, 3, 4, 5, 6, 7. You should recognize this and know that this is going to be a parabola that is going to, if we were to do the whole thing, it would be opening like that, opening down because of the negative x squared. But we're going to only be looking at this part of it, the right-hand side. So that's f of x. Label, very important to label. And then flip the points. So 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 1, 5, 2, 0, 3, and 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Okay, and it should not have arrows because we are starting at 0, 9 because our limited domain and we're finishing, 9, 0 should not have arrows, only on the down part of the blue graph and on the left side of the red graph. So if I draw in the line y equals x, and I forgot to label, this is my f negative 1 of x, my inverse. If I were to fold the blue, along the green line, the blue would fall on the red. It looks like it. The domain of f of x was x is greater than or equal to 0. They told us that. Then when you look at the range, you have to look at what is your largest y-coordinate. And I believe that it's 0, 9. And if you look at your table of values, they are all, and this is dot, 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 they're all smaller than 9. So the range is y is less than or equal to 9. Now if you look at the inverse, now the domain, if you look at the graph itself and look at your x-coordinates are getting smaller. So this is again dot, dot, dot. So your x-coordinates are now getting smaller. So now the domain of the inverse is basically very similar to the range of the f of x. And the range of my inverse, I'm looking at what are my y's doing? Well, my y's are getting larger than 0. And you can even tell, you look up and down for the range, you can see that the graph's getting higher and higher as it's going to the left. So y is going to be greater than or equal to 0. It's getting higher and higher, so the y's are increasing, but the x's are decreasing from 9. You might not have this piece, but based on these pictures, f of x and f negative 1 of x are inverses of each other over the line y equals x. Very important. All right, have a good night.